Third synthesis for furan is from carbohydrates. It's a two-step process. In the first step, distillation occurs for the CH bond using sulfuric acid. And in the second step, catalytic decomposition takes place in presence of steam. These are the reactions of furan. So furan goes under electrophilic substitution, as we have discussed the case of pyrrole. In the case of furan, the similar conditions are there. So the C2 substituted product are major product. These things we have discussed in detail, so we are not going to go into those details again. The one reason I'll tell you, you can clearly see from this picture, you have three resonating structures in the case of C2 substituted product. So this gives them higher stability to the product. Reactions, in case of reaction in the presence of acid, furan forms a C2 substituted product. Here there are two possibilities, as we have seen in the previous slide. So in the case of proton being substituted on the carbon 2, in the carbon 3, there are two different conditions arises. And when the C3 substituted intermediate is reacted with water, we get succinyldehyde. Now this is when your furan is reacted with the proton. In that case, we get succinyldehyde. Now some other electrophilic substitution reaction, if we react our furan with acetic acid and nitric acid. So this we have seen the similar kind of reaction in case of pyrrole. But what is different in case of furan? In case of furan, we are getting mono-substituted as well as di-substituted. And the substitution is occurring on the carbon consequence, which is present next to the oxygen atom. So in the case of furan, we are getting two products, 2-nitrofuran and 2,5-dinitrofuran. While in the case of pyrrole, we had seen only 2-nitropyrrole was formed. Similarly, if we do the sulfonation, here also we are getting two products. In case of chlorination, also we are getting two products. But in the case of acetic anhydride in the presence of BF3, there is only one product, and it is similar to the case of pyrrole. Now, reduction reaction. Reduction reaction we have discussed in the case of pyrrole also. So in this case, the complete reduction occur. If we see the case of pyrrole, let me show you the case of pyrrole here. In the case of pyrrole, we were reducing pyrrole using two different kind of reactants. One was zinc and acetic acid at room temperature. Other was using hydrogen gas with a platinum catalyst. So in the case of platinum catalyst, we were getting complete reduction, while in the case of zinc, the reduction was partial. So in the case of furan, we are using nickel as a catalyst and we are getting tetrahydrofuran as a product. That means a complete reduction. Now next reaction is Diels-Alder reaction. So in the case of Diels-Alder reaction, we have one diene and one dienophile, which reacts together to form a 4 plus 2 cycloaddition product. Alright. So in the case of furan, oxygen atom is highly electronegative. So the what happens when you have an aromatic structure? The delocalization of pi electrons occur. But since in the case of furan, we have a heteroatom that is oxygen, which is highly electronegative, the lone pair of oxygen will not be much delocalized. So what we have, this furan, this furan is acting as a dienophile, and we have this dimethyl malate, that is diester. In the presence of heat, it forms a cyclic structure, and in the adduct you can clearly see that these red light red lines indicates the new bonds form here. So if we see the mechanism, you can see this carbon atom is attacking here, and this double bond is being cleaved, and this carbon will have a negative charge which will attack here. Okay, this is a single step process, everything happens in the one step. And in the previous case, we were having different reactant. In the mechanism we have a different reactant. Here we have anhydride. In the previous slide we had diester. So don't get confused about that. Now 20 at 25 degrees Celsius, the adduct is being formed. Now here there are two possibilities. Either you can get an exo product or you can get an endo product. And the yield will depend upon the stability of your product. So exo is more stable, so it will be formed 90%. Now reactions. First very useful reaction that we have seen of furan is synthesis of pyrrole. In the last class we have discussed the synthesis. So the industrial process of pyrrole synthesis uses furan. Furan, when reacted with ammonia in the presence of alumina, gives us pyrrole. So this whole thing has been previously discussed. Now comes the medicinal use. Nitrofurans. There are many drugs which have nitrofurans in it. For example, furazone, furazonidone, nitrofurantoin. These are anti-infective agents, mainly used as anti-protozoal agent to treat trypanosomiasis and leishmaniasis. So these two